Let's solve question number 115. This question is from locus and constructions based on locus. Now there are 5 subparts to this question. Let's understand it part by part. So use a ruler and compass for this question. Part A, construct the locus of a moving point which moves such that it keeps a fixed distance of 4.5 centimeter from a fixed point O. So according to our locus theorem, the locus of this moving point will be a circle with the fixed point as the center and the fixed distance as the radius. So first we will construct a circle. So we need a compass and a scale. We need radius of 4.5 centimeter. So we will measure 4.5 centimeter and fix our radius. So we will keep our compass at a point. This is my center, and I'll draw a circle which has radius 4.5 centimeter. I will label the center of the circle as O. Okay, so this is part A done. Later on, I will also need to mention the locus, the description below the construction. We'll do that later. Now part B is saying draw line segment AB of 6 centimeter where A and B are 2 points on the locus obtained in part A. So locus obtained in part A is my circle. I need 2 points A and B on the circle such that the length of AB is 6 centimeter. Now I can choose the first point anywhere on the circumference. For example, let me choose point A over here. Then I need point B such that it's 6 centimeter away from A and it is at a distance, it's on the circumference. So I will need to measure 6 centimeter radius in my compass. And what I will do is from point A, which is on the circle, I will cut the circle at any point. I can cut over here, I can cut over here. It's my choice. So let me cut the circle over here. Then I will carefully mark the point of intersection. So this will be point B. And I will join AB, and AB should be 6 centimeter length. So this is part 2 done. Part B done. Then part C is construct the locus of all points equidistant from A and B. Name the points of intersection of the loci A and C as P and Q. Now we know that the locus of points equidistant from two fixed points will be the perpendicular bisector of the line segment joining the 2 points. So line segment AB is already drawn. I need to construct the perpendicular bisector of AB. So I will take a radius more than half the length of AB and then mark these arcs over here and over here. Same with point A with the same radius. I'll cut the previous arc here and over here. Then with my scale, I will join these 2 points. Okay, so this is my perpendicular bisector of AB. Now let me extend it a little bit further so that this perpendicular bisector, which is locus for part C, and the circle, which is locus for part A, they will intersect at 2 points and I will label them P and Q. So let's say this point of intersection I label as P and this point of intersection I label as Q. Okay. So part C is done. Then part D, join PA, find the locus of all points equidistant from AP and AB. So let me join PA. Now I need the locus of points equidistant from AP and AB. So I know according to our locus theorem, the locus of points equidistant from any two intersecting lines is the bisector of the angle between them. So the angle between them is angle PAB. I need to construct the bisector of angle PAB. So for that, I'll take my compass, put my center at A, any suitable radius, and I will draw an arc which is cutting the arms AP and AB. Then with some suitable radius, center at this point, I'll draw an arc here, and from this point I will draw an arc here. So I will locate the point of intersection of the two arcs, which is over here, and I will join point A with that other point. So this is the bisector of angle PAB. Okay. Then part E, mark the point of intersection of locus A and D as R. A was the circle and D is the angle bisector. So the point of intersection will be marked as R. My circle is here and my angle bisector is here. So they are intersecting at this point. So I will label this as point R. Measure and write down the length of AR. So I will take my scale and measure the length AR. So here I am getting the length of AR approximately 8.7 centimeter. So I will write. So now let me write down the description quickly. The description was, for part A, I had the locus as a circle with center O and radius 4.5 centimeter. Then I had to also write the locus of all points equidistant from A and B, which is part C. So I will mention for part C that the locus was the perpendicular bisector of the line segment AB. And then the part D was find the locus of all points equidistant from AP and AB. So for part D, I will mention that it is bisector of angle PAB. And for the last part, the length of AR is approximately 8.7 centimeter for my construction. Now, there are two answers given for the length of AR, and the reason is that when I constructed the perpendicular bisector of AB, it is meeting the circle at 2 points, and they asked us to label the points as P and Q. I have labeled this point as P and this point as Q. And then further they said, find the locus of points equidistant from AP and AB. So I took the bisector of angle PAB. Now it was also possible that instead of labeling this point as P, I could have labeled this point as Q. You don't have to label the same point with two different letters. You have to choose any one. But I'm just saying that there was another possibility that this point could have been Q and this point could have been P. In that situation, if anyone has done that, this point is P and then I have to join PA. So I would have joined PA this way. And then this is my angle PAB, and I would have to bisect that angle PAB. So if I do that, so then this will be the bisector of angle PAB in that situation, and this point would have been R. And then if I measure AR is approximately 4.8 or 4.9. So in that case, another possibility that AR length could have been about 4.8 centimeter. So that's the reason why the answer key mentions both the lengths, but it depends upon which point we have chosen as P and which point we have chosen as Q. Both are correct. Moving ahead to the next question. This is from constructions. Construction of a regular hexagon and its circumscribed circle. So question is, construct a regular hexagon ABCDEF of side 4.3 centimeter and construct its circumscribed circle, which is also known as circumcircle. Also construct tangents to the circumcircle at points B and C, which meets each other at point P. Measure and record angle BPC. Now, in ICSE, you would need to follow one method to construct a regular hexagon. And the method that they have asked you to follow for your exam will be that. Let's just draw a rough sketch first to understand. A regular hexagon will have 6 sides of equal length and all angles will be 120 degree. So you would need to construct one side length anyway is given, let's say AB, of 4.3 centimeter. Then you would need to use your compass to draw 120 degree angle and then cut off 4.3, and that will be point C. Then again at point C, construct 120 degree with compass, cut off 4.3 length, get point D, and then again keep doing the same thing, get point E, and then point F, and then finally join FA. So you would need to construct 120 degree angle 5 times to get your regular hexagon. And then you have to apply your knowledge of locus theorem to locate the circumcenter and then draw the circumcircle. Now theoretically, if you want to draw a circumcircle and you want to locate the circumcenter, the circle will pass through all the 6 vertices of the regular hexagon. So the center of the circle to any vertex, let's say OA, will be the circumradius. And the center is equidistant from all the 6 points. If I choose any 2 points, locus of points equidistant from 2 fixed points is the perpendicular bisector of the line segment joining them. So if I construct perpendicular bisector of any 2 sides of this regular hexagon, the intersection of those perpendicular bisectors will give me the circumcenter. And once I have the center, I can take a compass, put the center of the compass at the center, and the radius will be equal to the length of OA or OB or OC, and then draw a circle to get the circumscribed circle. Now, there is another method which is very easy and which will give me a very accurate regular hexagon, but it is not accepted in ICSE. So what we can do is we can still use that method to first construct the hexagon, and then we can try to show that we have anyway constructed the hexagon by drawing 5 120-degree angles. So that can be done. Now theoretically, what happens in a regular hexagon, if the side length is given as 4.3, the circumradius will also be equal to 4.3 centimeter exactly. That is the concept. So we will use this to first draw the circle instead of the hexagon. So you take your scale, take your compass and measure 4.3 centimeter radius. So you take your 4.3 centimeter radius in your compass, put the center and draw a circle. So anyway, this circle had to be drawn and I am drawing that first. This is my center. I will label it as O. Okay. Now I have to show that how I would have constructed my regular hexagon. Now the radius in my compass is already 4.3 centimeter. I can mark point A anywhere. Let's say I'm marking point A over here. Then I can take 4.3 centimeter and cut arcs on the circle. So this is one arc here. Then again from here, this is another arc here. Then again center here, another arc here. Then center over here, another arc here. Center over here, another arc here. So these are going to be my vertices B, C, D, E and F. And all I need to do now is join the vertices using my scale. So this is a very easy method to construct my regular hexagon and it's very accurate. But like I said, this method is not going to be accepted. So what I need to do is, after drawing my regular hexagon, I would need to show as if I have got the regular hexagon by drawing 120-degree angles. And that's going to be easy to do. Okay. So I got my regular hexagon, even the circumscribed circle. Now I have to erase these arcs as of now, because I don't want to show that I have constructed the regular hexagon in the other method. Anyway, the arcs were light, so just erase it a little bit. Okay, now what I need to do is I need to show construction of 120-degree angles. So I'll take my compass, take some arc, some radius, and I'll draw this arc over here. So anyway, this is my 120-degree angle, which is what we expected. So keep drawing the 120-degree arcs to show that you have drawn the hexagon by drawing 520-degree angles. Because they are also testing your skill whether you can draw 120-degree angles using compass and whether you know that the interior angle of a hexagon is 120-degree. So that's the reason why they would have wanted you to do this method. The only drawback is that it may not be very accurate, and the circumcircle may not pass through all the vertices. But the way I showed you, that method is very accurate. Okay, so this way I have 5 120-degree angles. And the side lengths are 4.3 centimeter. Now, even though I have got my circumcircle, I have to show how I would have been able to anyway get it. So first, locating the circumcenter, which is going to be the intersection of perpendicular bisectors of any two sides. So let me take AB and draw the perpendicular bisector of AB. So I'll draw the arc here and I'll draw another arc here. I'll cut the two arcs, one from here, one from here. So this will anyway pass through the center as expected. Let me take another side, let's say BC, and draw the perpendicular bisector of BC. So this also passes through the center, and the intersection of the two perpendicular bisectors is anyway my circumcenter O. And then using that center and radius equal to OA, I would have drawn my circle, which is already done. So this part of the construction is done. Then the remaining part was telling us that we need to draw tangents at point B and point C and then measure some angle BPC. So tangent means, suppose I have my radius OB. I will use the theorem that the radius and tangent are perpendicular at point of contact. So if OB is my radius, I can draw a 90-degree angle, and that will be my tangent. So center at point B, draw a 90-degree angle. So this is the tangent at point B. Same way, I will join OC, my radius. And I will draw a 90-degree with respect to radius OC at point C. So I already have this arc. There are a lot of construction arcs, but we need to be very careful and not get confused. So I have point C here and this construction arc, intersection of the arcs. I'll join them carefully. Okay. So I have these two tangents meeting at this point over here, and I have to label that point as P. So this is point P, and they have asked us to measure angle BPC. So you take a protractor, take any protractor and measure angle BPC. So if you want to extend this tangent a little bit further, that will help us measure the angle very accurately. Okay, so if you measure that now, so this is BP and this is PC, and this reading is 120 degree. So I will mention that angle BPC is 120 degree.